Welcome to India's most comprehensive e-learning platform, BYJU'S Exam Prep. In this evening, we all have gathered together to discuss the second part of the control system in this great Formula 1 series. First of all, I welcome every one of you to the second part of the control system. Of course, as you all know, we have started the journey of Formula series where we are about to discuss all kind of important concepts, all kind of important formulas, all kind of important results in a single spot. Correct? So Anita, good evening to every one of you. So many students are about to come because I have already forwarded the information. So just quickly 2 minutes, let me introduce myself. After that we will going to enter into the subject, right? So before going to discuss about the part 2, let me quickly explain about myself for the new students, because there might be some new students who doesn't know about myself. So myself, Phanindra, all put together, I have an experience of 12 plus years guiding for ECE students as well as GATE aspirants, everyone, right? And I am myself having an expertise in the subjects of control system, measurements and industrial instrumentation. And many students, they always ask a question to me, sir, why you wrote the GATE that many times, 11 times. But I would like to say, being a teacher, it is my responsibility to get updated with the actual trend of the GATE examination, correct? That's the only thing which motivates every time to me to write the GATE examination. Well, moving ahead, as I said, we are discussing about the Formula 1 series, and that too we are in the second part of the control system. First part of the control system I have already taken and you people really enjoyed a lot, right? So in the first part we have covered several topics. In fact, our journey started from the very much fundamentals, isn't it? We started from the fundamentals, basics were done, signal flow graph, block diagram reduction, whatnot, all other topics which are very important I have covered that, right? After that we have even seen the concept of stability. There I have explained the formula related to the RH criteria, Routh-Harwich criteria, and what are the important models in the Routh-Harwich criteria. All those things I have explained. After that, we have even seen the time domain specifications. I have explained what you mean by step response, impulse response, first order, second order. After that, I have explained the steady state error concepts. Many things I have explained, correct? And then we move to the next topic, that is root locus, and this topic is also done. So you all can see here almost 50% of the work we have done it in the first part, and now in this lecture we are going to discuss about the remaining 50% of the subject. That means all the important formulas, all important results, all important concepts which has to be addressed before going to the mock test as well as the final GATE examination. So let's quickly start with the frequency response. After discussing about the basics related to frequency response, then we will go to the next topic, that is nothing but frequency plots. I know that many of the students, they are asking about the frequency plot. Let me say one thing. Those who are attending this session, you will never regret. Okay, so that's what you have even seen in the first lecture also, right? So Rajashree, Namaskaram sir, Namaskaram, Kritik Samla, good evening, right? So now coming to the frequency response analysis, right? What do you mean by frequency response analysis? Frequency response analysis means we will apply the sinusoidal input to the system. That may be the first order system, that may be the second order system, that may be open loop system, that may be closed loop system. Any kind of system, we will apply the sinusoidal input. And while changing the sinusoidal input frequency, that means when we change the frequency of the input signal, the amplitude of the output as well as the phase will going to change. So the entire frequency domain response analysis will operate only on two things. That is, when we change the input signal frequency, how the amplitude of the output as well as phase are getting affected. Clear? So now I know that many of you are very much interested to go deep into the subject. So let me go deeply into the topic. But as I said, we will going to discuss majorly about the most important concepts. Clear? So you all can see there is a system. Don't ask me whether this is a open loop system or closed loop system. It doesn't mean that if I write only G of S, it is going to be open loop system. Basically, it is a system. It may be open loop system, it may be closed loop system, or it may be a sensor, or it may be a device, or it may be an amplifier. Anything it could be. But when we apply the input here, Ravi, good evening Ravi, right? So when we apply the input here x of t, you will receive the output as y of t. Now we have time. Today we are going to have the time because we need to complete only small portion because major chunk is already completed, right? So in frequency response analysis, all of you guys please answer me, what would be the x of t? What would be the input? Input would be, definitely I should say, x of t must be equal to what? A into sine, I should say, input frequency, let us say omega it plus some input phase here, correct? So A is called as the amplitude of the input signal, omega I is considered as a input signal frequency, phi I is considered as a input phase. So let me write down A as amplitude of input. Everyone, because we require to have the notes of this, so let me write down all these things, amplitude of input here, most important thing. And if you look at the omega I, it is nothing but the input signal frequency. So let me write down input signal frequency here, input signal frequency, and of course it would be in radian per second, and phase, that is input signal phase, correct? So input signal phase, that means sinusoidal signal phase. This is sinusoidal variation. Now what theory says is, whatever the system you might be having here, doesn't matter whether that is open loop or closed loop. Pramit, good evening everyone. Apu, good evening. So whatever may be the input you apply, doesn't matter. But at steady state, that means you will going to have a transient behavior in the output, but we don't encourage the transient response, because when we apply the sinusoidal input, we are only interested in the steady state response. That means at steady state, irrespective of anything. So that means if I say at steady state, definitely I would encourage and I would like to say that the output y of t must have again a sinusoidal input, that is B, right? Of course B into sine, again the same frequency will be there, omega I into t, but the phase will be different. Clear? So the phase will be different. If anybody want to know why the magnitude and phase are different, I have discussed some basic concepts related to frequency response in the YouTube itself. You go back to that lecture, there I have clearly explained what is the mechanism, why at steady state the magnitude as well as phase will depend on the frequency. All those things were discussed. But can you quickly tell what is important here? Because there are many questions only from this topic. So let me write down the amplitude of the output, which is nothing but B. Amplitude of the output, which is nothing but B, equals to amplitude of the input, of course, into the gain of the system or the magnitude of the system at the operating frequency. What is the operating frequency here? That is nothing but the input signal frequency only, correct? Input signal frequency itself, it is considered as the operating signal frequency. Now the most important question is, what would be the output phase here? The output phase can be written as the phase offered by the system plus input phase, correct? The phase offered by the system plus input phase. So let me write down input phase plus the phase offered by the system, that is phase of this system at the same operating frequency here. Now I have a question to every one of you. Please let me know one thing very clearly. Every one of you, there are several students are there, almost around 25 students are there in the live. You please let me know, if I change the frequency, what will going to change? Pramit and Apu, every one of you, please let me know. If I change the frequency, what will going to change? First of all, if we change the input signal frequency here, what will going to change? When I change the input signal frequency, the magnitude and phase of the system will going to change. Clear? The magnitude and phase of the system. Look at that. This value will going to change, magnitude, and this value will going to change, that is phase. That means for the input signal frequency variation or for the variation of the input signal frequency, the magnitude and phase of the system are going to vary. Note down this point. Vary. When they are changing, then naturally the amplitude of the output as well as the phase will going to change. Correct? So that means the first culprit is the system. First culprit is the system. Its magnitude and phase are affected by the variation of the frequency, and consequently the output amplitude and phase both are going to getting affected. That's why being an engineer, it is always our primary responsibility to see how the magnitude is varying with respect to frequency, how the phase is varying with respect to frequency. That's why we always try to draw the graph between frequency and the magnitude of the system, that is modulus of g of j omega, and even for the phase, that is nothing but phase of the system is this one. Clear? So we'll try to vary the input signal frequency, usually from starting frequency is 0 radian per second. After that we will increase the frequency, increase the frequency, we will even check at infinite radiation per second what will going to happen. Clear? Why we will do this one? Any one of you, can you please tell me why we are doing this one? Why we have to do this analysis? That means, what is the reason behind calculating the magnitude of the system as well as the phase of the system at different frequencies? Why we should do that? Because we know that when we change this frequency, definitely the magnitude of the system will change, the phase of the system will change. Inherently or consequently, the change in the magnitude and change in the phase will affect the amplitude of the output as well as amplitude of the phase, right? Then you may ask a question to me, sir, what will happen if the amplitude of the output and amplitude of the phase changes? If the phase changes, then the controller will get a delayed information and the overall system can be unstable. Clear? That's the reason why we need to see at different frequencies how the magnitude and phase both are going to change. So to understand that, we have several plots called frequency response plots. But before going to discuss about the frequency response plot, I would like to say some of the frequency domain specifications. Usually you will not find so many gate questions on this topic, but whenever you go for PSU examination or different types of examination, you will find some questions. Suppose if you take the frequency response of a system like that, clear? So assume that our system in this case, for example, if I say GS is equal to 1, in fact, omega n square divided by S square plus 2 zeta omega n into S plus omega n square. Don't argue with me whether this G of S is, a open loop system or closed loop system. Basically, it is a system. Okay, it is just a system, right? And many students, they will immediately raise the hand and say, sir, in closed loop system, when we are taking the closed loop block diagram, we have called G of S as a open loop system. Yes, of course. So sometimes we call K as a controller gain, sometimes we call K as a proportional constant, correct? So you must understand what is the name of that rather than alphabet. Clear? So this is very important to notice. Right, I hope you understood this. Now look at the beauty of this. If I write the magnitude, what do you call magnitude here? So suppose if I replace S is equal to j omega here, and I'm very sure you will be getting like G of j omega is equal to omega n square, and when I substitute j omega here, it will become minus omega square. So let me write down minus omega square and plus 2 into j into zeta omega n, right? So into omega will be there, and of course plus omega n square will be there, correct? So this is very easy to understand. And after getting this, if you want to calculate the magnitude of this, how do we write this one? So that means if you find the magnitude of this one, modulus of g of j omega, how can I write this one? So that is going to be your m of j omega, correct? So let me write down like this, m of j omega easily. So the numerator will be simply like omega n square. In the denominator, you will be having under root of, look at that, this plus this two are real part contributions. So therefore it would be like written like omega n square minus omega square whole square plus the remaining part is this one. So that could be written as a 4 zeta square omega n square and omega square. This is the way how you should write. This is the actual way, right? This is the actual way. But trust me, many of the students, they prepare some standard textbooks here and there. What they do is, they will take out this omega n outside. They take omega n outside and they cancel with the numerator and they replace omega by omega n as a normalized frequency, which is called as mu. There is nothing wrong. Even you can do like this or you can do like this, because as a experienced faculty, what I always believe is it is not required to remember so many things. It is required to know how you can do anything with whatever you know. Clear? That is more important. Clear? So now look at most important thing here is whenever you plot the graph here. So now you change the frequency here. Change the frequency omega here. So x-axis is omega and plot the magnitude. Plot the magnitude. Then you will understand that the magnitude plot will be like this, and most importantly there exists a frequency at which you will be able to see the maximum value or the peak value, and that is considered as a resonant peak. Clear? So this is called as a resonant peak. So let me write down this as a resonant peak here. Resonant peak, and the frequency at which we are getting the resonant peak is called as a resonant frequency. Clear? And this is not only important in control system, it is also equally important in analog electronics, circuit theory, everywhere, correct? Everywhere it is very important. Now look at that. So what is the value of the resonant frequency? That is an immediate question from your side. So let me erase all this stuff here, because ultimately you require the formulas only, right? So because these things I have just explained so that you will be able to recall the basic concepts whatever we have discussed in regular sessions. So omega r could be written now as equal to omega n into under root of 1 minus 2 zeta square. Now I have a question to everyone. Just assume that zeta is equal to 0. Just look at that zeta is equal to 0. What will going to happen? Any one of you, can you tell me? Every one of you. Today I think I haven't asked any question to anyone. Ravi, Rajeshri, Hritik, Anita, Chandrasekhar, Kamdula, Sudhira Gupta. Tell me what happens if zeta is equal to 0. If zeta is equal to 0, you must understand here, when you keep zeta is equal to 0, omega r is equal to omega n. It means at the natural frequency of the system itself, we will get the peak value. You will going to get the peak response from the system. Peak response of the system. What does it mean? At this frequency, that means when the input signal frequency is equals to omega r, you will be seeing the maximum response from the system. That means system will give maximum response. Clear? That is the meaning of that. Now if zeta is equal to 0, when the input signal frequency equals to natural frequency, at that time you will going to see the peak value. Clear? So there was one good question. I have seen this, I think a few years back, around 9-10 years back. They asked this question. For an undamped system, look at the question. For an undamped system, at what frequency we will get the peak value? At what frequency we will get the peak value of the system? The moment when they say that at what value of the frequency, immediately should understand that yes, that is frequency domain specification. And it was clearly mentioned zeta is equal to 0. So that means at the natural frequency, you will going to get the peak value for an undamped system. Clear? For an undamped system. I hope you understood this. Moving ahead, what is going to be the resonant peak? Simple. Again, I told you what is the meaning of this, particularly omega r divided by omega n is equal to mu r. So if you want, the maximum or the resonant peak, just you need to use this formula, nothing else. And if you want to substitute omega r, take omega r and substitute here, no problem. Nobody will going to say anything to you, correct? So this is the general formula. However, there is one more important specification here. Sir, do we observe the same characteristics for frequency response in frequency? Yes, Premit, right. Yes, we observe the same things, correct, right? So the bandwidth is another important characteristic, and of course this is a big formula. And those who want to know the derivations of this thing, you can refer my lectures in BYJU'S Exam Prep app. Just go to the BYJU'S Exam Prep app, download the app, and there you can find the recorded lectures of control systems taken by me. There you can find the derivations of all those things with a very, very clear and beautiful examples. Okay. Now, what do you mean by bandwidth? Bandwidth means it is a range of frequencies from the 0, or else it is a range of frequency where your gain or magnitude of the system will not follow or will not fall less than 1 by root 2 times of your DC gain. What is the DC gain here? That means at low frequency you have 1. So it will be 1 here. 1 by root 2 into 1. So that means it should be, the magnitude should not fall below this value. That means what does it mean? The magnitude should be above this value. Above this value means above this value. Correct? Up to what frequency the magnitude is above this value? So up to this frequency. That's why we call this total frequency range as bandwidth here. Clear? This is a formula for the bandwidth. And if you don't want to remember, I can't say anything, but you have to. Clear? So Pramit is asking some questions. Sir, do you need to remember bandwidth expression? That's what I'm saying. Because in GATE examination, take the transfer function and look at the frequency where your magnitude is equal to 1 by root 2. Finished. Then you will going to get directly the value of the bandwidth. Clear? So if you don't want to do that much of it may take just maximum of 2 minutes, maximum 2 to 3 minutes if you have good practice. If you can remember, remember this. If you don't remember, remember at least how to approach from the basics. Clear? So I hope you understood that. Surya is asking, hi sir, hi. Is it clear so far? All of you please let me know, because there are around 30 students are there. So is it clear so far? Because we are going to enter into the frequency response plot. So I want all of you to participate in the session very immensely. Clear? So now coming to the most important plot of the frequency plot, that is Bode plot. Right? So yes sir, clear. Now you see, I told you that what is the need to have this table. What is the need to have this table? This table will inform you what happens to the magnitude and phase when the frequency changes from lowest value to the highest value. Omega 0 is considered as a DC signal. Omega is equal to infinity is considered as the highest frequency signal. So obviously it will be very easy for me if I have some plot which I have some graph which shows the relation between magnitude versus frequency and phase versus frequency. Clear? So keeping that in the mind, people have investigated and came up with a new thought that is nothing but not new thought. At that time, before this was invented, that was a new thought, right? So people came up with the idea of Bode plot. So Bode plot, basically it will have two plots. One is, as I was saying, magnitude plot. Now I will ask so many questions to you, so please be ready with the pen and paper and let me know at each and every point. Phase plot. What is the difference between the magnitude plot and phase plot? In magnitude plot, we will take magnitude, let me write down, modulus of g of j omega specifically. And if you want for the closed loop system, we will write like modulus of g of j omega into h of j omega. Clear? So this versus we will take the input signal frequency, omega. Omega stands for input signal frequency. And here we will take the phase of the system, right? G of j omega. If it is the open loop system of closed loop system, then phase of g of j omega into h of j omega will take. Means we can do the Bode plot for any system. We can do the Bode plot only for g of s, only for h of s, or g of s into h of s, or anything. Clear? Basically these are mathematical tools. These are mathematical tools and they can be applied to anything. So here again, this is phase versus frequency. Clear? So phase plot is all about phase versus frequency. Magnitude plot is always magnitude versus frequency. I hope you understood up to here. Now tell me, in logarithmic graph and in Bode plot, suppose if you take magnitude. So magnitude we write in dB here. That is, usually this is nothing but 20 logarithmic of, if you take only for g of s, then it would be like j of j omega. Clear? And the frequency should be on logarithmic graph. Why we should use logarithmic graph? Any one of you? I will give 2 minutes time because this was one of the fantastic questions asked for me in many of the interviews, and so many interviews I attended, and I found lot of times this question. Why we need to use logarithmic graph here? Any one of you? Any one of you? Why we need to use logarithmic graph? To get linear scale, for easy to handle. Okay, good. Maharaj is saying easy to handle, right? So can't we handle otherwise this if it is not this? I will tell you the actual reason. Look at that. First, Pramit is saying something like to get linear scale. Good. So what does it mean? It means that suppose let us say I have 20 here, I have 40 here. Clear? So at omega 1 we have 20 dB and at omega 2 we have like 40 dB. Clear? Suppose if I say omega 2 is equal to 10 times of omega 1, what does it mean? If omega 2 is equal to 10 times of omega 1, it means that it is called as a 1 decay change, right? 1 decay change or 1 decade change in frequency. Clear? Suppose if omega 2 is equal to omega 2 times of omega 1, we call this as octave change. Clear? 1 octave change. Octave change in the frequency. Now I will tell you what is the logic behind this, right? Suppose if you take like this, can you please tell me what is the slope from here to here? So I am asking what is the slope of this value, this line. Slope of this line can be simply written as, let me write down this as a slope. This slope could be written as, how can I write slope? y2 minus y1, correct? Divided by x2 minus x1. What is y2 here? 40 dB minus 20 dB, correct? So relax that and tell me. So 40 dB minus 20 dB. So these two numbers here, 40 minus 20 dB divided by, what should I write here? So I should write down this as a log omega 2 minus log omega 1 here. Clear? Log omega 2 minus log omega 1. So higher frequency as well as lowest frequency in scale. Excellent, Sudhakaran. I was about to expect this value. Sanjay is also saying correct answer. Sudhakar is also saying correct answer. Prashant Maharaj is also saying correct answer. Very good. Excellent. So now when I take log omega 2 minus log omega 1, what will going to happen here? So log omega 2 minus log omega 1, I can simply put it in this way, that is log omega 2 divided by omega 1. Many students, they don't know this algorithm also, right? So omega 2 divided by omega 1. बताओ क्या हो सकता है इधर? So omega 2 by omega 1. If you look at carefully, this will going to become like 20 dB here, undoubtedly. And here we will be having like log of. Look at the beautiful way here. Omega 2 is 10 times of omega 1, correct? So 10 times of omega 1 divided by omega 1. Now it will get cancelled. So then it will be equal to what? 20 dB per 1 decade. So we call this as 1 decade here. Clear? So 1 decade, 20 dB per 1 decade. That is considered as a slope and it will become linear, number 1. Number 2, most important thing is, you can keep the lowest possible frequency here. Suppose if I start with 0.1 here, then 0.1 will be here, and maybe, so you can expect here 1 here. So the 10 times increase, 0.1 to 10 times increase means 1. 1 to 10 times increase means 10. Then next you are going to have 100. The beautiful part here is, when you are in the logarithmic scale, the space between this and the space between this will become same. Clear? The space will become same. So that will create a linear understanding for you. And second most important thing is, after 100, you can even see 1000, that is 10 cube. And then you can even see 10 power 4. That means it is easy for you to locate the higher frequency on the graph. Because most of the systems are high frequency systems, there are low frequency systems also. That means we need to understand the performance of the system at low frequency, even at high frequency also. Correct? Being an engineer, it is your actual tendency to know the behavior of the system at low frequency, even at the high frequency also. Correct? So if I am an engineer, I am very curious to know every system. Correct? So that's why we need to have the lowest frequency here as well as the highest frequency, and that is possible only in the logarithmic scale. And I really appreciate the people who already given the answer, but as I know, some of the students who are not giving the reply, they might not be knowing the concept. That's why I have explained this, right? So now moving ahead with the first topic, that is Bode plot. So in Bode plot, suppose if you are working for some kind of transfer function, right? Let us assume that you are working for g of s here, for example, right? Or you can work for g of s into h of s also, as I was saying, right? So what would be the first step we need to do? We need to replace s is equal to j omega. Then it will going to become g of j omega. And right immediately after that, you should take the magnitude of this function. So let us say the magnitude of this function is modulus of g of j omega, and the phase of this function is going to be phase of j omega here. Clear? So you must understand, after getting the magnitude and phase, we must change the frequency. Suppose let us assume that modulus of j omega is coming like 1 divided by 1 plus under root of 1 plus omega square. Then we need to change the frequency, understand the magnitude, plot the graph between omega and magnitude. That is called magnitude plot. And if you do the same thing for phase, then it is called as a phase plot. These things you know very well. Now I have a question. Everyone think logical and tell me, because most of the students, they were, those who attended my sessions or anyone's session, you might be knowing that if I have the transfer function as g of s is equal to 1 by s, tell me what will going to happen here. What will going to happen? You have pole of order 1 at origin. Whenever you have pole of order 1 at origin, or poles at origin, or zeros at origin, your graph will not start from omega equal to 0. Why? Any one of you? Narasimha, you are late today, right? Anyway, good evening to you, right? So now you must understand whether even if the poles are at their origin or else zeros are there at the origin, graph will not start from omega is equal to 0. Rather, it starts from omega is equal to 0.1 or 0.01 radian per second, which is very, very low in the nature. Why? Any one of you? Kandula Sudhir Gupta, Sudhakaran, can you tell me why we cannot start from omega is equal to 0 when we have poles or zeros in the transfer function at origin? Suppose let us say we have g of s here is equal to s. Assume that s, right? So the problem with this is magnitude. If you look at that magnitude of j omega, what you will going to have? You will be simply having like omega, correct? So if I take magnitude in dB, so the 20 log of modulus of j omega, particularly it will going to become like 20 log omega. Very happy about it. But if I say omega is equal to 0, what you will going to have here? It will become 20 log of 0, correct? 20 log of 0 may be very, very high value, right? And this value we cannot keep in the plot. Such a high value we cannot keep in the plot. That's why some people says that we cannot define that value, right? So therefore, people suggest that don't try to keep the value at omega is equal to 0. Try to keep the omega is equal to 0.1 or 0.001. Clear? So this is the first thing what I need to say. And suppose, let us assume that, for example, I have some magnitude plot here. So let us assume that, right? So there is a omega here, and there might be a chance that we have like modulus of g omega in dB. So let me say it is in dB, or else 20 log of modulus of j omega, let me write. So just give me 1 minute time. I know all of you are very sincere and serious students. That's why I'm writing everything here. So just give me 1 minute so that I will come up with the best value. So that is 20 logarithmic of modulus of j omega. Right? So now, for example, if at all, if the plot says that it is started from point 1, right immediately you must understand that there might be a possibility to have 0 at origin or pole at origin. Correct? That is the first conclusion you have to draw. First conclusion is, if omega is equal to 0.1, immediately you must understand that there might be a chance that a pole at origin or 0 at origin can exist. Clear? Then the question is, how do we define that? So suppose let us say this might be 0.1 here, or it may be 1 here, or it may be 10 here, something like this. Clear? Just assume that if the magnitude plot of poles at origin will have minus 20 dB, magnitude plot will have minus 20 dB, minus 20 into n dB per decade. Good. Suppose let us say we have plot which is something like this, 20 dB here, right? And maybe at 1 it is coming like this. Clear? So now tell me, what is the slope of this line? So if the slope of this line is very simple, right? So 20 dB is the decrease. 20 dB is the decrease for an increment of 1 decay. Correct? For an increment of 1 decay. Therefore, straight away I can say there is a chance to have only the slope of this line could be written as, look at that, slope of this line could be written here now as minus 20 dB per decay. So, right? Slope is equal to minus 20 dB per decay. Excellent. Minus 20 dB per decay. So that indicates that we have g of s is equal to 1 by s here. Clear? 1 by s here. So easy to understand. The most important thing is this. That is, here if you have poles, then the slope will going to decrease. That means it will create a negative slope. Pole always create a negative slope. 0 always create a positive slope. Or 0 will add the slope, add the gain, or pole will going to decrease the slope. Clear? So please remember this point. I hope those who attended the control system classes anywhere, you might be knowing this point, right? So now, for example, if I say the slope is equal to 40 dB, then what will going to happen here? So if I say the slope is 40 dB, then it means that we have 2 poles at origin. Clear? 2 poles at origin, then it will be written like minus 40 dB here, right? So likewise, depending upon the number of poles here. So let me erase this one. So exactly these things, I feel that you people might be knowing this, right? So yes. So now magnitude plot will change the slope if the transfer function or if the function has g of s is equal to 1 divided by s power n. Clear? So that means the number of poles, order of the poles here, that will decide the slope here. So if you have 1 pole, then minus 20 dB per decay. If you 2 poles here, then it will be minus 40 dB per decay. 3 poles will be minus 60, likewise. Clear? So similarly, if you put the other way around it, right? Suppose if you have zeros, what would be the situation? So phase, of course, phase will be constant, that is minus 90. So suppose if you have g of s is equal to 1 by s, of course its phase will be minus 90 here, right? Minus 90. So if you have s square, then it will become 2, minus 180 degrees, right? So therefore, if you have n here, then it will be having minus 90 into n degree. So these things are quite natural, and reverse will going to happen for the zeros. That means in case if your transfer function has s power n, then the slope will change like a positive value, right? So that means slope will be increased by an amount of 20 into n dB per decade. These things are very, very important, and phase will be constant at 90 degrees. Hope you might be knowing these things very clearly. Now all of you, please let me know in the comment section. So far everything is clear. Are you able to revise with me, or am I moving a bit fast or slow? What's your opinion? Every one of you, tell me. Is the speed is okay, or you want me to reduce or increase? Okay, both I can do, no problem. Yes, good Kandula, correct, excellent. Right? Now let's move on to the next one, that is magnitude plot. Suppose here it is all the way we have understood clearly that this is all about the poles are zeros at origin. This is all about poles are zeros at origin. But what would be the situation? Suppose if I have some function like g of s is equal to 1 divided by s plus 1. What does it mean? It means that when I have like this, it is not the pole at origin, rather we have a pole at -1, correct? Pole at -1. So that means they are real poles other than origin. In that case, what should happen? Simple again, magnitude plot for a pole of order n, right? Here also we have a pole of order 1 here, correct? So it will create a slope change, or the slope will change by an amount of -920 n dB per decade, and reverse will happen in the case of zeros here. However, you must understand, in case if you have a constant gain k, the magnitude plot will shift by an amount of 20 log k. Clear? Magnitude plot will shift by an amount of 20 log k. You may argue with me, sir, how does it really happens? Suppose, let us say here we have, right, k here. So we have k here. So look at this way, the way how I am going to do here. I will write this g of s as k into 1 divided by s plus 1. Clear? 1 divided by s plus 1. So maybe I can find that, 20 log of g of j omega, naturally it will going to become what? 20 log, or else we can even write like this also. So let us look it in the other way around it. Okay. So just call it as this k. Let me call this as the g1 of s, and let us call this 1 by s plus 1 as the g2 of s. Clear? So if this is the case, what will going to happen if I substitute s is equal to j omega here? So then g of j omega, naturally it will going to become like k into 1 divided by 1 plus j omega, correct? 1 plus j omega. Then if I take magnitude of this, magnitude of k, g of j omega, it will going to become like modulus of k first, right? So mod of k will be k only, and modulus of 1 plus 1 j omega here. Now look at the beautiful thing. If I take 20 log both sides here, 20 log of modulus of this, then I am very sure that it will become 20 log of k plus this one, because basically it looks like this. 20 logarithmic of, you will be having like k into 1 divided by under root of 1 plus omega square, that is the magnitude here, correct? So then if you break it so successfully, what you will be having? In simple way, it will become like 20 log k plus you will be still having like 20 log of 1 divided by under root of 1 plus omega square here. Clear? So that means this 20 log k, that is going to be added to the existing gain if you have k in the numerator of the transfer function like this. Clear? So that's why I told you that the magnitude plot will all the way shift by an amount of 20 log k, and however a constant value in the numerator, that is gain, will not be affecting the phase. This is very important to know. I hope I have explained everything clearly here, right? And there is a small concept that is there between, 1 second, let me wait for 2 minutes. All of you, hope you understood these things, right? So that means whenever you have a constant gain k, that will add a value of 20 log k to the existing plot. And apart from that, one more important thing is, whenever you draw a plot, magnitude plot, that is omega here, or logarithmic graph omega, fine. So here 20 log of modulus of j omega, that is magnitude here, good, this is also fine, right? So if the plot is something like this, then this is called as a exact Bode plot. But if you take the approximate Bode plot, asymptotic Bode plot, let us assume that we have one pole or corner frequency here, let me say omega c1. So usually in approximate Bode plot, what we do is, up to corner frequency we will going to approximate it, and then we will draw like this. Clear? Slope. So the blue color one, whatever I have written here, this is called as asymptotic Bode plot. Clear? Asymptotic Bode plot. Now you tell me where there is a possibility to have more gap between the asymptotic Bode plot and exact Bode plot. Any one of you? Exact Bode plot. Where do you find the maximum difference between the asymptotic Bode plot and exact Bode plot? Any one of you? Look at this graph and tell me. There are around 30 students are there, so let me know. So usually at corner frequency, we find lot of difference between the asymptotic Bode plot and exact Bode plot. This is very, very important concept to know at corner frequency. Sanjay is saying corner frequency. Correct. Excellent. That is the point you must remember. Now, the gap will not only decided by the corner frequency, it also depends on the how many corner frequencies. What is the order of the corner frequency there? Suppose if you have, maybe there is a chance that g of s is equal to 1 by s plus 2 whole square. If you have in this way, then the corner frequency is considered as a 2, right? As we have square here, then it is called as the order of 2. Clear? So that is the way how you should see. I hope you understood the difference between corner frequency and what is the difference between exact and asymptotic Bode plot. So mostly I have covered whatever is required in Bode plot. Now let's go to the polar plot, right? So whenever I start the polar plot, most of the students, they expect some kind of shortcuts here, right? I guess almost around 8 to 10 years back, when I was teaching polar plot, I do teach with the, I really made it like that. I generally teach with the basic concept and some shortcuts. Like if it is a type 1 system, then it will go like this. Type 0 system, it goes like this. Type 2 system means this is the way how it looks like. What I understood is, after teaching so many shortcuts, students dropped the basic concept and they started following the, shortcuts. And I really faced one situation. One of my student who attended for IIT Madras interview, just before going to the interview, he called me and asked, "Sir, what is polar plot?" I was really felt on that day that teaching too many shortcuts is also a problem, because many students will forget the concept. And truly speaking, up to now in the GATE examination, every question on the polar plot came only on the basic. It is not really so much of magic you need to do for polar plot. So whoever wants so many shortcuts and all these things, you can refer my notes or the classes. But here I will give a basic approach and a simple shortcut or simple approach which can be used in anywhere. Okay, so let me give that one. So polar plot means what? Basically it's very simple plot. So again, whether this is the polar plot or Bode plot or Nyquist plot, you will be having g of s. That is the first one, right? So we will replace s is equal to j omega. That is the second step here. Every time we must do that, replace s is equal to j omega. Fine, absolutely good. Then you will going to get g of j omega. Immediately right after that, we need to find the magnitude of this one. So magnitude is equal to modulus of j omega, right? And then phase. The phase would be written as the phase of j omega. Clear? Then what we do is, we will develop the polar coordinates like this. That means we will take frequency here and magnitude of the system and phase of the system, both simultaneously. Clear? Both simultaneously like a vectors, right? So now you can keep omega is equal to 0, omega is equal to infinity, something like that. So let me ask you a simple question here. Suppose if you take g of s is equal to s. For example, I am taking like g of s is equal to s. What I am saying, first step is replace s is equal to j omega, right? Then it will become like g of j omega is equal to omega, j omega here, and then modulus of g of j omega is what? Modulus of g of j omega is equal to omega only, and the phase of this would be equal to 90 degrees here. Clear? 90 degrees here. Now look at that. What should I write here now? It should be written as omega at an angle of 90 degrees, because the phase remains same. Phase is 90 degree and frequency is omega. Now magnitude is omega. Now the easiest way is, after finding this, just start with the DC frequency or DC value, that is 0 frequency. That means what should I say here? As I was requesting you, keep omega is equal to 0. When I keep omega is equal to 0, this is becoming like 0 magnitude at 90 degrees phase. That means the magnitude of the vector is 0, phase is 90 degrees. Now keep omega is equal to 1. Then the magnitude is 1 and this is going to be 90 degrees. Likewise, you can keep 10, 100, anything, but anyway finally we will keep infinity. If I keep infinity, then the magnitude will go for infinity. However, the phase remains constant. Clear? Phase remains constant. But what is polar plot basically? Polar plot means it's a plot drawn on the polar coordinates. So that means it starts with the 0 degree here. Of course, this would be 90 degrees here, right? And this would be 180 degrees here. And this could be said as a 270 degrees. The same 270 degrees, if you come this way, then it would be written as minus 90 degrees, and this would be considered as minus 180 degrees here, and this will be considered as minus 270 degrees here. Clear? So you must understand both the different logics here, right? So because many times we will use both, that's why it is important to know everything. Now tell me, what should I do here? Simplest way is, as I said, there is a first vector here. The vector magnitude is 0 and phase is 90 degrees. Where it will be? Vector magnitude is 0, but phase is 90 degrees. Where it will be? 90 degrees axis means this. Correct? 90 degrees axis means this. Right? And magnitude is 0, phase is 90. That means magnitude is 0 means it's a point. Correct? It's a point. So just like that. And what would be the second vector? Second vector is 1 at an angle of 90 degrees. That means draw a vector which has a magnitude of 1, length of 1 unit and phase of 90 degrees. So that means let me draw a vector here. So which has 1 is a magnitude, but as I said, 1 is a magnitude and phase is 90 degrees means same axis. Correct? And then of course if you keep omega is equal to 2 here or 10 here, what will going to happen? If I keep omega is equal to 10 also, then it will become 10 at an angle of 90 degrees here, isn't it? So that means you have to draw one more vector which has a magnitude of 10 but still phase is 90 means same axis. Correct? Phase is 90 means same axis. Then if you go for infinity, magnitude is infinity, phase is 90. That means if you go for lot of frequency, finally you will be having same thing like this. That means you will be having a huge magnitude here with the same phase of 90 degrees. Clear? So this is the way how the vectors will be adjusted here. What we do say is, look at the beautiful point here. So this is the tip of the first vector. This is the tip of the second vector. This is the tip of the third vector. This is the tip of the fourth vector. Tip of the fourth vector. This is considered as a tip of the fourth vector. Now first vector has a 0 magnitude, phase of 90. Second vector, third vector, fourth vector, like that. Now we have to connect all these tips, right? So connect all these tips means this is the only way you can connect here, correct? So then see how easy it is, right? So you got 90 degrees here. So this is considered as a polar plot. Simple, right? This is considered as a polar plot. Tell me all of you, is it easy, right? Many of you may ask a question, sir, this is just only yes. You have taken only for yes. If it is a complex function, then how do we draw this? I am saying that even if it is complex function, it is better to believe the basics. I will tell you how it is, right? So this is one way. Now suppose in case if I ask you a question, okay fine, let us take some of the most famous one here so that you will get some confidence here. So let me take here, most popular or what you say, like very frequently asked question, right? So assume that this is polar coordinates here, right? So instead of yes, you can even take like 1 by s plus 1, no problem, right? So let us take 1 by s plus 1, right? And here also, now today those students who are attending my session, I am very sure you will get these beautiful ideas here. So because I do agree that many students knows this, but most of the students don't know this, right? That's why I need to explain. So g of s is equal to 1 divided by 1 plus s, and if you replace s is equal to j omega, then it will become like 1 by 1 plus j omega. Then what is the magnitude j omega here? So let me write down this side here. So magnitude here for this function, now it will be equal to how much? 1 divided by under root of 1 plus omega square. And what would be the phase? Phase is equal to minus tan inverse of omega here. Clear? Minus tan inverse of omega, right? Now listen carefully. Keep omega is equal to 0. Only 3 frequencies, not many frequencies. Only 3 frequencies are sufficient. 3 to 4 max. Omega is equal to 0. What would be the magnitude here? Keep omega is equal to 0 here. What you will be having? 1 phase of 0 degree here. Well, and when you keep omega is equal to 1, then what you will going to have? Substitute omega is equal to 1 here. Then it will become 1 by root 2. Of course, it will become, what is the phase? Tan inverse of 1, that is 45. Minus is there, minus 45. Now relax. Third vector is what? I have told you that take omega is equal to infinity. If you take omega is equal to infinity, then the magnitude will become 0. Phase will become minus 90 degrees here. That means there are 3 vectors here. One is at starting, one is at ending, and one is at some other frequency. Correct? Starting, we have the magnitude. Look at the first vector here. How do we write? Magnitude is 1 and phase is 0 degree. Correct? Magnitude is 1. Very good, very good. Magnitude is 1 and phase is 0 degree. How do we write? Magnitude is 1 means the vector should have magnitude of 1 and phase is 0 degree means on 0 degree axis. Clear? 0 degree axis. Hold on. Next, when I keep omega is equal to 1, magnitude is 1 by root 2 and phase is minus 45 degrees. Correct? So that means what I am doing, minus 45 degrees is the phase and the magnitude is 1 by root 2 means it should be less than previous length, right? Maybe something like this. Clear? And you can see the third one, at omega is equal to infinity, the magnitude is 0 and the phase is minus 90 here, correct? So therefore I can write down here exactly in this way. That means again it is a point, because whenever the magnitude is 0, it is just like a point. It's a point, right? And phase is minus 90 means on minus 90, you should have length 0. That is the meaning of this. Therefore, if I join the tips of all these things, then you will going to get polar plot. So clear? So that means look at that. This is here and this is here and this is here. Clear? Polar plot. Now join all these things, we will going to get a simple polar plot here. And of course, this is considered as a polar plot now. That means here it is considered as omega is equal to 0 and omega is equal to infinity, the magnitude is tending to 0. Clear? So the magnitude is tending to 0. This means it is a pole dominated system. Clear? Omega is equal to infinity, magnitude is tending to 0, means it is a pole dominated system. Clear? Polar plot is semicircle and it is lag compensator. Excellent, Banerjee, very good, nice, right? So now honestly tell me, those students, almost 35 students are there now, let me know, have you got the easiest way? Can't be strict to this particular procedure. What is the requirement for us to know about the different types, different poles, 10 to 15 formulas in a basic concept, right? Yes, I agree with that. It may take 1 to 2 minutes extra time, but you can really, challenge your answer, right? Because if you start remembering the type 1, what should I apply? Type 2, what should I apply? And in the process of confusion, in 3 hours of pressure, definitely you will commit the mistake. This is my personal experience. And even the gate questions are not so difficult on polar plot, where you require just 3 frequencies evaluation, draw the vectors first and keep the vectors connected, and then you will going to get the answer. Yes, Pramit is agreeing with me, right? So that's why I always say that believing the basics and doing the faster calculation by practicing more questions, by using the basics is more appropriate rather than remembering thousands of formulas. Clear? How many of you agree with me? One is Pramit is saying yes. Sandhya and Kandula, other students, what do you say here in polar plot? Yes, only one yes, right? Yes, yes, good, right? Yes, agreed, right? Very good, nice. That's why I'm saying, and I'm not against of remembering the different formulas in polar plot. If you can remember, of course you are genius, so you can do that. But as I'm saying that for gate, most of the times you will be asking the basic questions, then you can go and keep 3 vectors here, plot the vectors, connect that. Oh, there is a power cut here, so okay, this came. Right. So guys, are you able to hear me? Just please message me if you are clear in my voice. Is it okay? Are you able to hear me? It's coming here. Just 2 minutes. Yes. Please listen and tell me, are you able to hear? Yes, we can. Yes, thank you very much. Right. Now, let me explain the way, because so far I have explained the concept of polar plot and you people agreed with me very well. No problem, Ravi. After the class, you can come back once again and, listen the complete lecture. Ravi, you can attend the class, regular class, but after the class, come back once again and listen all the concepts what we have discussed. Now, let me tell you the Nyquist plot story. Nyquist plot story, here you can see we are changing the omega is equal to 0 to infinity. Correct? Omega is equal to 0 to infinity. And even physically that is possible. Physically we can change the value of omega is equal to 0 to infinity, because omega is considered as the lowest frequency and 0 is considered as the lowest frequency, infinity is considered as the highest frequency. But trust me, what if mathematically if we have something to cover from omega is equal to minus infinity to infinity, clear? Minus infinity to infinity, right? So minus infinity to infinity, if the frequency changes, how the phase and magnitude of the system will going to change. It doesn't matter whether I really apply the negative frequency or not, but what if? That is what Nyquist plot says. Now what I am trying to say is, can I write like this range, right? So something like this, minus omega is equal to infinity to 0 minus, clear? So 0 minus means just before 0, and can I break like this, and again 0 plus, so to omega to infinity. Can I write like this? This is considered as a polar plot. Here this is considered as a polar plot, right? So usually we call this as a polar plot. We call this as a polar plot, and we call this as mirror image of the polar plot. Clear? Mirror image of polar plot. Image of polar plot, right? So polar plot. That means it clearly says that whatever is happening, polar plot, once again give me mirror image of polar plot. Now it clearly says that whatever the polar plot is there, if I can draw the mirror image of that, then you will going to get the mirror image of the polar plot, correct? So these two will contribute the significant amount in the Nyquist plot. So how many of you came to know this point today itself? Please let me know this analysis. How many of you came to know today itself? So I want everybody to see, I want to see your response here. So this is the way how I understood. Honestly speaking, you will not find this kind of understanding in the books. Okay, you must do the practice and understand the things. So usually minus infinity to infinity, we will try to explore the frequency response, right? But logically, if you apply common sense and divide minus infinity to 0 minus, that means just before 0, right? And just after 0 to infinity, that is considered as a polar plot here, correct? Simple logic. Now you must ask a question, if you are clever enough, what happens exactly at omega is equal to 0? That is the real game change point, clear? That is a game changing point. And those who want to know what happens between this change from 0 minus to 0 plus, so those students who want to know this, you can refer my as I said, this is really a very interesting ball game. BYJU'S Exam Prep, download the app and you can view, you can watch my lectures if you want to get a full concept there. But let me not disturb the actual intent of the Formula 1 series. I'm just giving an idea that what to do here. Sorry sir, I am unable to. Okay Ravi, no problem. You can go for next class, right? Sir, yes, my next question was that only. Excellent. That's what I'm saying. 0 minus to 0 plus, that quick change in the frequency of a very less value, what it will going to do. Clear? If you want to know that, refer the classes. But I will give an example here so that you will get a better idea here. So that means, suppose let us say g of s is equal to 1 divided by s into s plus 1. Clear? 1 divided by s into s plus 1. I am taking this example. Okay. So then obviously we replace s is equal to j omega here. Then g of j omega would be what? G of j omega is equal to 1 divided by j omega into 1 plus j omega. And then magnitude will be what? Modulus of j omega is equal to, I am very sure those who know this, they will be knowing very well. So 1 divided by omega into under root of 1 plus omega square. Correct. What about the phase here? The phase would be written as equal to, of course it is minus 90 degrees minus tan inverse of omega. Clear? Minus 90 degrees minus tan inverse of omega. What we have made it. Now what is our intention? Our intention is just to see omega and first try to construct the polar plot. Right? Try to construct the polar plot. That means magnitude and phase. You look at only these two things here. Right? So magnitude and phase here. So suppose as I was saying, let me keep the first frequency as 0. Clear? So I am taking 0, positive value. Sir, your videos are very helpful to revise the control system in best way. Thank you very much, Abhishek. Thanks for your compliment. Thanks for your love. Thanks for your, once again, I really very happy to get this much of huge response from you guys. But please focus here. Omega is equal to 0. What is the magnitude here? Suppose if we keep magnitude, of course, put omega is equal to 0. Then it looks like infinite here. Correct? Simple. Magnitude at low frequency, if it is equal to infinity, means it is a pole dominated system. It is a pole dominated system. What about the phase here? Substitute omega is equal to 0 here. So when I substitute omega is equal to 0 here, tan inverse of 0, it will be 0. Minus 90 minus 0, obviously it will be minus 90 degrees only. Correct? Minus 90 degrees. Right? Now today, if you are able to draw the Nyquist plot for this, it's sufficient. You will understand the way how to draw the Nyquist plot or anything, right? But I told you that, see, it is not like 0. I want to take first like keep like 0 only. Next, let us take for 1. If I take for 1, fatapat tell me what is the magnitude, all of you. 30 students are there in the live. Everybody should active. Where is Appu, Prashant Maharaj, and Pramit, Vicky, and Sudhakaran? Please let me know. Lionized iconic. Naam pata nahi hai, but so keep omega is equal to 1. Tell me what is the magnitude. Magnitude is, if you substitute omega is equal to 1 here, it will become 1 by root 2, isn't it? 1 by root 2 is the magnitude. What about the phase here? If you substitute omega is equal to 1 here, instead of 0, how much phase you will going to get? Substitute omega is equal to 1. Tan inverse of 1, 45, minus 45, and of course it will be minus 135. No doubt about that, right? I told you take one more point, that is if possible you can take 1 by 100 or 10 or 100 anything, but it's better wise, because I know that after a lot of practice you can take directly infinity. If you take infinity, it is a pole dominated system, so it will become 0 magnitude and phase will become minus 180 degrees here. Minus 180 degrees. Relax. Relax. Now think carefully, because we are in Nyquist plot, which is a little bit dangerous. So please see. So now remove all this stuff here, because already you know the transfer function and the phase and magnitude and all this calculation. So please listen carefully. Right? So first of all, the function is what? First of all, the function is g of s is equal to 1 divided by s into s plus 1 or 1 plus s. Anything is fine, no problem. 1 plus s. Now first draw the polar, polar plane. Polar plane means, as you know, we will be drawing like this, right? So let me take like this, and this side it is going to be written as either minus 90 degrees and this is going to be minus 180 degrees. Now I can take, for example, and this is minus 270 degrees, right? Now first vector, where is the first vector now? First vector is very important here, so please try to understand. So the curve intersects at minus 180 degrees line. Good. So please see. Now what I told you, this polar plot start from 0 plus, correct? That means don't take omega is equal to 0. Take omega is equal to just a value which is more than 0. Maybe 0.001 or 0.0002 like that. That means if you take omega is equal to 0 plus, correct? Only at omega is equal to 0, it will become infinity, correct? So now it will not be equal to infinity, just less than infinity, magnitude is. And the phase is also not minus 90 degrees. The phase might be like, how much here at omega is equal to 0 plus, if I say, it will not be minus 90 degrees, rather it will become like, minus 89.99 degrees, something like this, minus 89.9 degrees, something like that. That means magnitude is very high, very less than infinity, but phase is not minus 90 degrees, minus 89.89999 like that, correct? So therefore what should I say? It is a large magnitude, very heavy magnitude, but the phase is minus 89.999 something like that. So I am not going to keep exactly on minus 90, right? So sorry, it is just more than minus 90 degrees, just it's not minus 89.9. I am extremely sorry, because I hope you remember that the phase is how much here? The phase of the system here is minus 90 degrees minus tan inverse of omega, right? So substitute omega is equal to 0.01, right? Then you will going to get phase is equal to minus 90 minus some small value you will be having, right? So then definitely it is above the minus 90. So let us assume that this is, otherwise let me take calculator and do it, because some students may question here, right? So tan inverse of 0.01. What would be the value here? So 0.5. So minus 90, 0.5. So it is 90.5. So that means all the way I can say it is minus 90.5 degree approximately. That's why I have written the graph here. So this is the first vector with a huge amplitude, almost infinity, But if you look at the phase from here to here, it is going to be 90 degrees, minus 90 degrees 0.5, sorry, minus 90.5 degrees. Clear? I hope you understood this, how to select, right? 90.5 degrees. Are you able to understand so far here? So please let me know, is it clear to all of you or not up to here? So it is minus 90.5 degree. That is why the this line is coming just this side of minus 90 degrees. Is it clear all of you? Please let me know the first vector. So the first vector is actually nothing but, what is that? First vector is nothing but this one, that is 0 plus up to here. Correct? Is it clear to all of you? Please let me know. Passion of heart, good evening, good evening. Every one of you, please tell me. 0 plus means just more than omega is equal to 0. Magnitude is very high and the phase is also coming minus 90.5 degree. That's why I have written a line which is exactly like this. Is it clear? Yes. Very good. So other students, please look at what will happen when I keep omega is equal to 1. Magnitude is 1 by root 2, phase is minus 135. This is very easy. 1 by root 2 magnitude means it is some magnitude. So let us say this would be this one, correct? So this vector will have this length 1 by root 2 and the phase from here to here it is going to be minus 135 degrees. Look at that, it is coming exactly in the middle. This is minus 135 degrees. Well, very good. Extremely happy to say this point. But now I would like to ask another question to you. What is the last vector now? Last vector omega equal to infinity, magnitude is 0, phase is minus 180 degrees. That means it's strictly a point with 0 magnitude and phase is minus 180 degrees, minus 180 degrees axis. Now these 3 points should be connected, right? So these 3 points should be connected. That means this is the way only it will be connected, because the phase is never going less than minus 180. That means we are not getting minus 181, minus 82, minus 182, minus 183, minus 184, minus 185. We are not getting that. Anything that will only lie below minus 180 degrees, that is minus 179, minus 168. That's why it has to all the way now trace in this particular way. Look at the beauty of this, right? So just give me one value here, right? So this is easy to understand, right? So this is exactly the way how the polar plot looks like here. Polar plot looks like this. And what would be the frequency here? The frequency here is 0 plus. Clear? Omega is equal to 0 plus. And the frequency here, as I was saying, omega is equal to less than infinity, right? So less than infinity means, okay, just infinity minus, I should say. Less than infinity means, right? So that is one thing. But what about this one? Minus infinity to 0 minus. That means the mirror image of this, correct? So how do we take the mirror image of this one now? Mirror image of this, very easy. I think you people are clever enough to take this one, right? So let me take another color here. Mirror image of this, obviously it looks like this, correct? So let us take the mirror image of this, one second. Mirror image of this, right? So mirror image of this, correct? This is exactly considered as a mirror image of this, right? So now we have a mirror image of this also. And most importantly, the arrow marks also we can keep. So for the mirror image, I am very sure that if your graph is going in this way, and as I was saying, this will go obviously in this way. Clear? So let me take, otherwise, first of all, don't do anything here. So now, oh my God, sorry, extremely sorry. So this will come all the way like this. Right? This is exactly the way how you will be having, right? So now just tell me, after getting this, what we should do? Is it the complete plot for you? Appu, please tell me. Appu and Premit and other students, Natarajan, please tell me, is it the complete plot for you? No. This section indicates this one. And this section indicates this one. But what is between from 0 minus to 0 plus? Of course, there is a lot of procedure for that. I do agree with this, because it is not the time for me to discuss about the complete procedure. But my suggestion is, once you draw this one, take 2 points here. End of the mirror image. Look at that. This is going to be the ending of the mirror image. Ending of the mirror image is the first point. Starting of the original graph is the second point. This is the second point. End of the mirror image. This is mirror image. Correct? This is mirror image. End of the mirror image. Clear? End of the mirror image is this one, and starting of the original graph is this point. And these two should be connected with the infinite radius in clockwise direction. infinite radius in clockwise direction. That means how does it is possible? So let me erase this one here. All of you please look at this. So these two, end of the mirror image and the starting of the original graph, both must be connected with the infinite radius in clockwise direction. So that means, look at the beautiful point, ending of the mirror image and starting of the original graph, both should be connected in clockwise direction with the infinite radius. That's it, connected. So that means this is the direction here. Clear? So this is the direction. I should say all the way this is connected like this. And now tell me, in the mirror image, what should be the direction? Starting, you know, it is coming like this. Starting, it is coming like this. And this section also, you know, like this. Then obviously this section must be having the direction like this. Clear? This is called as a Nyquist plot. Clear? This is called Nyquist plot. Yes. Yeah. No. Arrow direction, I didn't say that. Follow the mirror image for arrow direction. I told you that this mirror image should be followed only for the plot. Only for the plot, not for the arrow direction. Finally, the arrow direction should follow the complete loop. Clear? So please look at this. This is very important. You have asked really wonderful question. I just asked that take the mirror image of the plot, but I didn't say that follow the mirror image direction also. Correct? So take the plot only for mirror image of the only plot. For direction, you should apply common sense. Okay? You should apply common sense. How I applied the common sense? As I was saying that clearly, from the starting of the, ending of the, this is end of the mirror image. This is end of the mirror image. End of mirror image, let me write down, this is m dot image. Clear? And this is the starting of the original graph. This is starting of original plot. Plot means original plot. Original plot. Starting of the original plot. This should be connected. So that means from here to here, this is the only way the direction should come. Clear? So thank you, sir. I got it. Yeah, very good. Very good. Excellent. After plotting this graph, then try to plot the direction for this. That is the way even I also done that. After a lot of experience, I also followed the basic only. Correct? So if you start plotting the arrows right immediately at the starting, you will do the mistake. First plot the graph and then try to understand how to close this one. This is Nyquist plot. Now tell me, all of you are okay with this? Every one of you. 35 students are there. So please let me know, is it clear to all of you or not? But again, I am requesting you, this is the short way to write this. 99.9% of the times, right? Finally, it should be counter which? Yes. Very good. Excellent. Correct? This is the way how the contour will come now. Nyquist contour. But I suggest that this is not the best way to know the basics. So for basic understanding, go to BYJU'S Exam Prep app and listen my lectures. As some students are mentioning here that they enjoyed the Nyquist plot. Nyquist plot, you will see the completely different approach in the easiest language. But this is a conclusion. Clear? And there is a little bit drama here at origin, whether this will go this way or this will go like this. Okay. So to understand what exactly is happening here, how the circle is forming, right? Because it's not possible that it will going to become suddenly changed, right? There might be a chance that here it will go and first take a round here, right? It may go and take a round like this and then go, right? So then this is the way how it comes. Clear? So what is exactly happening here? If you want to understand these things especially, you must know the actual concept. Clear? But up to here, whatever we have done, we have really done a very good analysis here. So let me stop here and don't want to mess up here. Clear? So Pankaj, very good. So now all of you, please let me know, really will you appreciate this Nyquist plot approach? Those who appreciate this, many students are saying that yes sir. But again, I want to say that this is sufficient for exam. But being a my student, you should also know the basic concept behind this. Clear? This is about Nyquist plot. So guys, I think sufficient. Let me go with the next topic, that is gain margin and phase margin. So the gain margin and phase margin are the concepts which are used especially to know the stability analysis. Yes, further analysis will come. Now I will show you how we can do the stability analysis for the Nyquist plot. Just wait for 10 minutes, I will complete it. Okay, right. So here gain margin and phase margin are the concepts to know the stability of closed loop system from G of S into H of S. That means if the loop gain is given, how do we identify the stability? That is the job of gain margin and phase margin. Clear? So now the very first thing, if you want to get the gain margin, because I can't discuss now like what is the definition of gain margin, what is the purpose of gain margin too deeply and all. So let's go and discuss about the important concepts only. Right? The very first thing is, if you want to find the gain margin, you should find the phase crossover frequency. ये क्या है? Omega PC. This is the frequency at which the phase of this open loop function, that is j omega PC, the phase of this function must be minus 180 degrees here. Clear? Minus 180 degrees. Clear? The phase should be minus 180 degrees, right? And the second is, calculate the magnitude at omega PC. That means at that frequency omega PC, we should find the magnitude. That is the function, second point. Third is, take the inverse of that. That would be called as a gain margin. In fact, people do call that as a kg. Clear? Gain margin. And if you want in dB, that is gain margin in dB. If you want to calculate in dB, what is the value? 20 logarithmic of kg. Simple. 20 logarithmic of kg. Because if you get this as a gain margin, the dB value is nothing but 20 log of kg. So if you want gain margin, first the phase should be at minus 180 degrees. That means phase should be at the border. Clear? Right? Sir, what about that infinite radius half circle? Yes, that is what I am saying. If you want to know that exactly, then you have to go for basic understanding. Right? So now, so phase is minus 180 degrees as I was saying. Right? So once you fix the phase, then find the magnitude at that phase and take the inverse, then you will get the gain margin. Clear? Most of the students, what they do is, they will find this value and they will keep that as itself as a gain margin. No, that is not the correct way. Clear? Now if you want the phase margin, then we need to find the omega GC. What is omega GC here? Which is called as the gain crossover frequency. That means if you want phase margin, first the magnitude should be fixed at omega is equal to 1. Clear? So that means this omega GC can be found by taking modulus of this value, that means magnitude of j omega into h of j omega GC equal to 1. Be clear about that. And then next immediately we will calculate the phase at that point. And once you calculate the phase at that frequency, then we will add it to the 180 degrees to calculate the phase margin here. Clear? So these are the general steps to find out the gain margin and phase margin. However, if you want to know the in-depth meaning of that, you have to go for the regular classes. But these are the final conclusions, what I am writing here. And how do we find the stability from here? Simple. The stability analysis can be done like this, right? So look at that. So in case if omega PC is more than omega GC, omega PC is more than omega GC, then the gain margin is positive, phase margin is going to be positive, and the system is going to be stable. Which system? This is a closed loop system. CLCS means closed loop control system. Clear? And if omega PC, omega GC both are same, then you will going to have no margin available at phase and no margin will be available even at the gain. That means zero margin at gain, zero margin at phase. Then you are at the border of the stability, that is marginally stable system. Suppose in case omega PC is less than omega GC, clear? Omega PC is less than omega GC, then phase margin will be negative, gain margin will be negative, the system will be unstable. That is closed loop system is unstable. Most of the times you will be able to solve these questions easily. Now I have a question. Sorry, extremely sorry. Let us assume that we have some system. Okay, this is some random system. So ये क्या है वो क्या है बता. So just it is a simple system. It is a simple system G of S. I am saying that this system has omega PC is equal to infinity. Okay, assume that this system has omega PC is equal to infinity. If I get omega PC is equal to infinity, can this system be unstable? Is it possible for this system to become unstable? Look at that. Is it possible for this system to become unstable or not? Take some time and tell me, is it possible for this system to become unstable or not? Everyone you must answer. Is it possible for this system to become unstable? No. Why? Because I told you that if omega PC is greater than omega GC, then the closed loop system becomes stable. Now, omega PC is infinite means omega PC itself, it is a very high value. Then how omega GC can cross omega PC? If omega PC is here, omega GC will be less than that value only, correct? So then you will be always with the first condition, so the closed loop system will become stable, correct? So if suppose if omega GC crosses omega PC, then there is a chance that the system will become unstable. That is the reason why what people say is always try to have the maximum value for phase crossover frequency, because if you have more value for omega PC, then omega GC cannot cross the value of omega PC. The closed loop control system will be always in your hand, that is stable system. Clear? So that means what should be the ideal situation? Ideally, you do anything in control design, whatever the way you can do, whether you want to add the pole or delete the pole, whatever you want to do, you can do that. But the great important point is, you must notice the fact that you need to have more value for omega PC. Clear? That's the overall situation. Right. Now, how do we find the gain margin and phase margin from the Bode plot? It's very simple. Look at this and tell me what will be the situation now. Now, as I was saying, if you want phase margin, look at that. Suppose this is omega GC. If you want phase margin, catch the omega GC and draw the line here. Right. So just this line may cut here. So let us assume that this is minus 160 degrees. Clear? Then tell me what is the phase margin here. Every one of you please tell me what is the phase margin now. Any one of you. Phase margin is 180 degrees, as I was saying, plus phi GC. That means the phase at gain crossover frequency. What is the phase at gain crossover frequency here? That is minus 160 degrees. Correct? So therefore, I could say this one as 180 degrees minus 160 degrees. Obviously, this will be equal to 20 degrees here. Clear? This will be equal to 20 degrees. Any proof for stability? Oh yes, yes, very many, so many proofs. But as I suggested, no. So I refer that because my class, whatever I have handled the regular classes, so many proofs I have discussed, like what will happen if omega PC is less than omega GC, more than omega GC, like that. So my suggestion is, please watch the lectures only on gain margin and phase margin, and all your queries like this, that will be clarified. Clear? Because if I started explaining the proof now, the proof itself, it will take around at least 20 to 30 minutes clearly by taking different examples, right? Then that's the problem. I actually want to explain the proof, right? By heart I want to explain the proof, by mind I want to complete this, because this is the second part, I have to make it. Okay, so right. Now next part is, this is phase margin. What about the gain margin here now? So this is omega PC here, correct? Gain margin, look at that. At gain omega PC, draw the line to the magnitude plot. This is cutting here. Maybe I am very sure if you draw the line, it will going to have minus 20 dB here. So it is in dB. So what does it mean? So I am very sure that minus 20 dB is going to be at omega PC. At omega is equal to omega PC, the magnitude of the system, that is modulus of G of j omega PC, it is coming down to be equal to minus 20 dB. Correct? So minus 20 dB. Then what is the gain margin now? So the gain margin is, right, in normal way you will take 1 by this, but in just like a glimpse, sir. Yes, very good. Right. So one reciprocal we will take in normal value, but reciprocal we cannot take in logarithmic. You have to take minus of this value, that is minus 20 to 20, so it will be of 20 dB. So inherently what it means, that is like you have still to add this value here. Okay, you have still to add this value like this, right? Now so he is asking like iconic. So he is asking some question, sir, can you make it to understand this way? So do one thing, in the same graph, okay, right? So if you try to take, exactly omega PC, omega GC, if you increase the gain, add 20 dB to this one. For this plot, add 20 dB. If you add 20 dB, what will going to happen here? So then obviously this graph will going to cut like this, correct? So then this will going to become omega GC. Clear? So now you see omega GC at exactly omega GC. That means if you add 20 dB to this line, so one second, let me write down like this. For this white color magnitude plot, if you add 20 dB, then what will going to happen? Each and every point will rise like this, correct? Every point will rise like this, and then this is the way how it looks like, correct? So that means the new plot is this. This is the new plot. After the addition of this, then the new plot will cut 0 dB here, at omega GC. Now look at that. At omega GC, if you draw a line here, it will cut at omega PC only. Now if you look at this point, minus 180 degrees here. Correct? Minus 180 degrees. Now my suggestion is, in this case, what is happening now? What is happening? Now in the second case, case 2, I am absolutely happy to say that omega PC is equal to omega GC. Omega GC and omega PC both are same. Correct? Omega GC and omega PC is same. That means when I added the gain to this one, it shifted to this, and now we got to know that omega PC is equal to omega GC, and gain margin, phase margin both will be 0. Why? Because at this point, if you draw the graph, it cuts omega PC at minus 180 degrees. You don't have any phase to add because you are already at border. And from omega PC, if you draw the line to the yellow color line, omega GC, there you have 0 dB. There also you cannot add anything. That means at this situation, gain margin and is equal to 0 dB and phase margin is equal to 0. Clear? That is 0 degree. So therefore, you can't add anything, then the system will be marginally stable. Clear? This is the way how easily you can understand. Then if you still add something to this, right, then just imagine that if you add this, then maybe another plot may come something like this. Clear? Another plot may be able to come, if you still add, then this is the way how it comes. Then omega GC might be here. And at that time, if you see, the phase will go to the minus 190, 200 like that, then the phase margin will become negative. Clear? So I hope you understood the way how you can find the, phase margin and gain margin from the Bode plot to understand the stability. And once you calculate the gain margin and phase margin, you should follow this table. So look at that. First case, phase margin is 20, gain margin is plus 20 dB. So therefore I can say it is positive, the closed loop system is stable. Clear? That's it, right? Yes, thank you very much. For you only I explained. This is a polar plot. Okay, so let me take about the polar plot quickly here. So polar plot, as I said, the stability analysis from the polar plot. So polar plot is straight away very easy. Here we will draw the polar plot first. So this is polar plot. Let us take this as a polar plot. This is a polar plot. Clear? This is polar plot. Now you need to know at what frequency this is exactly the magnitude becomes 1. That's why what we do is we will draw a unit radius circle. When we draw the unit radius circle, see, this is considered as a unit radius here. That means this circle is unit radius circle, and this circle is cutting exactly at this point. So let me say this is the point where it is cutting the polar plot, and that point is considered as omega is equal to omega GC here. Clear? Because your frequency always starts from omega is equal to 0, and this might be omega is equal to infinity here, because the plot ends here. Correct? Omega is equal to infinity. Now look at that. At omega is equal to omega GC, the polar plot is cutting the unit radius circle like this. Excellent. Agree? Very happy? Right, no problem. Now at that frequency, if I want the phase margin, how do we find the phase margin? First of all, look at the phase of the plot here. Clear? So this is the phase of the plot. So phase of the system at omega GC, therefore it is considered as a phi GC here. Clear? This is considered as a phi GC. Then how could I find the phase margin now? Now phase margin is 180 degrees plus the phase of the polar plot at that point. So because this is nothing but a vector here, right? So this is actually a vector, one of the vector in the polar plot construction. This is one of the vector, isn't it? This particular, this is all the way from here to here. This is a vector, isn't it? So that is what exactly we have found here. Now phase margin is clear. How do we find the gain margin here? For gain margin, it is very simple. Just look at on minus 180 degrees axis, because this vector, whatever I write here, this vector, it means that this vector of the polar plot, indicates that the phase is minus 180 degrees, and here the magnitude may be like L. So L is going to be this. What is L here? So the L would be written as a modulus of G of j omega Pc into H of j omega Pc. Clear? That means the frequency at which the phase becomes 180 degrees, at that time the length of the vector is nothing but the magnitude of the vector. Length of the vector is nothing but the magnitude of the vector. But what is your gain margin now? Now the gain margin could be written as 1 by L. Clear? Gain margin is written as 1 by L. This is the way how you will be able to find. But just think the way how I am thinking. So please look at this. We started from omega is equal to 0 and the frequency is slowly increased. Then in the middle we got omega is equal to omega GC. Still we increased and this might be the frequency omega PC, because you see polar plot cuts at this value minus 180 degrees, correct? So at omega is equal to omega PC. Now you tell me whether you got omega GC first or omega PC first. Whether we got omega GC first or omega PC first. So you started from 0 degree, omega is equal to 0. Slowly you are rising. When you are rising slowly, first you got omega GC. After that we got omega PC. After that we got omega equal to infinity. Tell me whether omega GC is more or omega PC is more. Omega GC is more or omega PC is more now. Now I can tell you from this logic clearly, in this case, omega GC is coming first when I am changing from 0 to infinity, right? So therefore omega GC is less compared to omega PC. Very good, excellent, Pranit, right? Omega PC. Therefore I can say the system is, closed loop control system is stable. Clear? So let me write down, it is stable here. Clear? It is going to be stable. Now I have most important information to you. Just let us say we have some graph like this. Okay, so just tell me we have some graph like this, right? And maybe the unit radius circle starting itself I am keeping here. So this is a unit radius circle. Okay, very good. Now in case if I say the plot all the way, it is having like this. Clear? Like this. Now you tell me, if I have the plot like this, again this is the direction of the frequency. So now tell me what we can say here. So this plot is cutting minus 180 degrees here. This is minus 180 degrees. So this is minus 180 degrees. The plot is cutting minus 180 degrees here, means this is omega PC. This is omega PC. And it is cutting unity radius circle here, means this is omega GC. हम लोग को पता नहीं है क्या है ये वैल्यू ओमेगा पीसी ओमेगा जीसी. We don't know what is the value. We don't know what is the value. But if you apply common sense, we are raising the frequency, correct? We are increasing the frequency from omega is equal to 0 radian per second, and we are about to celebrate final value as omega is equal to infinity. In the journey of 0 to infinity, now you saw that omega PC is coming first, omega GC is coming next. So which is high, which is less? Very good. Now omega GC is very good, Praveen. Right? This leads to omega GC, absolutely it is going to be more than omega PC, or in another way I will write like this, because this would be more appropriate if I write in the reverse way. Right? Omega PC here, it is less than omega GC, so the system will be unstable here. Clear? Unstable. Right? So this is the second situation. Now look at the situation where this, I will draw one more graph to ask you the last question. Which color I will take? Let me take this color. In case if I have like this, then look at this third one. Now this is going to be omega PC here, and that is the same frequency where even the magnitude became 1, correct? In that situation I can say omega GC is equal to omega PC, then the system is marginally stable in the green color case, that is this case. Clear? So that is how one can easily say from the values of omega PC and omega GC, intelligently we can say whether the system is stable or unstable. Is it interesting? I am seeing the number is not decreasing, not more than 2 to 3 students. Excellent, very good. I really appreciate your patience. Is it really interesting? Please let me know. Have you understood the different way to sense here? Yes. See, now you need not to calculate all these things. Directly we will be able to say by looking at the graph whether the system is marginally stable or unstable. Have you understood these concepts clearly or not? Please let me know. Yes. Yes, sir. Interesting. Right. Now the stability analysis from the Nyquist plot. So good. As I was saying, the Nyquist plot, let me take one simple Nyquist plot and tell you. Right. So we have some g of s. So let us assume that g of s into h of s we have. Clear? So this is considered as a open loop transfer function of closed loop control system or loop gain, because this will participate in the characteristic equation. So this is very important for us, right? So now, yes, right. Now let me draw the Nyquist plot first, because some students asked previously what is the analysis we have here. Yes, that is what I am trying to say now. Look at that. Minus 90 degrees, minus 180 degrees, and minus 270 degrees. Excellent. Okay, I appreciate here. Right. Now just think logically and tell me, if it is this, assume that we have some kind of Nyquist plot, right? Maybe like this. So just assume that, right? So this is polar plot. This is a polar plot here. Now you must notice one fact here. For this polar plot, you know, the phase will be always more than minus 280 degrees. Irrespective of the frequency, the phase is always minus 270 degrees. Correct? So what does it mean? You are already crossed minus 180 degrees. It means that the system will be unstable. Correct? Because phase margin always it will be negative for this. Correct? So anyway, this is the polar plot. How to draw the Nyquist plot now? So simple. As I was saying here, just take the, you know, mirror image of this one first, fatafat here. So the mirror image of this, let me take another color here first of all. So the mirror image of this, and don't get trapped just by taking the direction of arrows, don't do that. So this is the ending of the mirror image and the starting of the original graph. Clear? End of the mirror image, starting of the original graph. These two should be connected in clockwise direction with the, extremely sorry, right? So infinite radius. Kaisa ho sakta hai ye? So then just imagine that the ending of the mirror image should be connected to the starting of the original graph with the infinite radius. This is the only possibility. Correct? So then I can say this should be definitely a clockwise direction. Clear? This should be a clockwise direction here. Clockwise direction, and then obviously this will going to become now, this is the only possibility now, right? So this way. Then after drawing this in Nyquist plot, what we do is, this is considered as minus 1 comma 0 point. Minus 1 comma 0 point means phase is minus 180 degrees and the magnitude of this number is equal to 1. So just look at that. If in the complex plane, minus 1 comma j0, this could be the point. Minus 1, 0 could be written as minus 1 plus j0. Iska magnitude kitna hai? Magnitude is going to be 1. Magnitude is 1. And phase is how much? Phase is minus 180 degrees. This is called critical point of stability. Right? So magnitude 1 means modulus of g of j omega into h of j omega equal to 1. Phase is equal to minus 180 degrees. That is called critical point of stability. So minus 1 comma 0 is called as a critical point of stability. After getting the critical point of stability here, what must we do here? Simple. Just critical point of stability, as I said, then at critical point of stability or minus 1 comma 0, look at that how many anti-clockwise encirclements are done about minus 1 comma 0. Anti-clockwise encirclements. So here we have a great formula from Cauchy's theorem, right? Those who want the proof of this, mathematical proof, physical significance and practical implications of this, if you want to know, you refer the Nyquist plot lectures only in my lectures, that is in app. Then I have taken around 7 lectures only on the Nyquist plot. It detailsly explained, you know, each and everything, right? Why closing circle can't be on right hand side. No. This is a shortcut. If you want to know what is the background of this, then you need to know the entire concepts on the. That is what I was saying from the starting onwards, right? So why you should not do this side? Because this shortcut I have got after practicing so many questions. Okay, this is the conclusion. If you want to know what is the answer for why, then you need to naturally look at the whole concept, right? So that's why I'm again and again referring that at least Nyquist plot, have patience and go through my lectures, okay, my lectures, and I am sure you will not get any doubts. And if you don't have that patience, then you need to go with this. Then look at the number of anti-clockwise encirclements about minus 1 comma 0, and in this case, this P is considered as open loop poles. Number of open loop poles in right hand side. 1 second. Yes. So for time being, let me write down, because this is important formula. P is considered as number of open loop poles in right hand side RHS of S plane, and Z is considered as number of closed loop poles closed loop poles in right hand side of S plane. Clear? Right hand side of S plane. Now relax. Relax. Sorry sir, my live is buffering, that's why. Okay, no problem, no issue at all, right? So no problem. So now you tell me, yes, P and Z, I have explained what it is. Now look at the number of encirclements. How do we find the number of encirclements? Very simple. Just draw a line from here, correct? Draw a line like this. Now you see this line, whatever you have drawn from -1, 0 is cut by the Nyquist plot. Yes or no? Yes, it is cut by the Nyquist plot. And in the cutting, so this is clockwise or anti-clockwise? Look at that. This is clockwise encirclement or anti-clockwise encirclement? It is cutting like this, right? So it is cutting like this. So it is clockwise, correct? So if it is clockwise, then n would be taken as the -1. Clear? N will be taken as -1 because it is cutting clockwise. So n is equal to -1. Right? Most important thing is this n could be written as anti-clockwise encirclement. Anti-clockwise encirclements. Clear? And encirclements, number of anti-clockwise encirclements. Clear? In this case, n is equal to -1. Suppose let us assume that somebody told that g of s into h of s, okay, has no poles in the right hand side of S plane. If somebody told that g of s into h of s has no poles in the right hand side of S plane, what does it mean? That means open loop function is stable. So this means that this function has no poles in the right hand side of the S plane, means open loop system is stable. Our number of open loop poles in the right hand side of S plane is 0. Then P is equal to 0. So I told you that n is equal to P minus Z here. So right now n is equal to -1. So P is 0 minus Z. So Z is equal to 1. So what does it mean? Z is equal to 1 means, this means the system whose Nyquist plot is like this. The system whose Nyquist plot is equal to the system whose Nyquist plot is, like this. That system has one pole in the right hand side of the S plane. The closed loop system has one pole in the right hand side of the S plane. So the closed loop system is unstable. When the closed loop system becomes stable, if Z is equal to 0. If Z is equal to 0, then the closed loop system becomes stable. But Z is equal to 1 means number of closed loop poles in the right hand side of S plane is equal to 1 and the system is unstable. Clear? This is the way how actually we will find the closed loop system stability, by looking at the number of encirclements and number of poles in the right hand side for the right hand side of the S plane for the open loop system. Clear? If N and P will be given in the exam. N, you have to get it from the Nyquist plot. If you know these two things, you can say what is the value of Z. And if the Z value is known, then you will understand the number of poles or the number of closed loop poles in the right hand side of S plane. And that gives the information about the stability. Clear? So I hope you understood this one, right? So still, once again I am saying that those who want to master the Nyquist plot, do you want me to take separate lectures on Nyquist plot? So let me see how many of you are interested. Do you want a complete mathematics clear understanding about the Nyquist plot? You can message in the comment section. Yes sir, we want a separate lectures, because truly speaking, so many messages I am getting. So even I requested the management also to provide the separate series of lectures, 4 to 5 lectures only on Nyquist plot, so that the in and around the mathematics, the complete physical significance and everything can be taught. Okay, if you want that, you can actually keep in the comment section. Yes sir, we need everything. Otherwise, if you want to complete it fast, you can even do that from the lectures also. Both, anything is possible for you, right? So now there are 3 different things like minimum phase system and non-minimum phase system. These things I feel that many of you might be knowing that. Usually minimum phase system means it will contribute the negative phase. So a control system is said to be minimum phase system if and only if all open loop poles, look at that, all open loop poles and open loop zeros are placed in the left hand side of the S plane. Clear? And the non-minimum phase system means a control system is said to be non-minimum phase system, right? So if at least any one open loop pole or open loop 0 is lies in the right half side of the S-plane. Then it is called as a non-minimum phase system. And all pass system is symmetrical poles should be there. A control system is said to be all pass when its frequency response of magnitude is constant for all frequencies. Suppose if you have the pole 0 plot something like this, clear? So just like this, if you have poles and zeros plot, right? So then, you know, one second, I'm sorry. You know, if you have something like this, it is a deadly combination of minimum phase system and non-minimum phase system. So if you have maybe like a pole this side and 0 that side, right? So then it is considered as a all pass system, simple, right? So let us take pole here and at the same time, so it is a 1 and it is a -1. This is the nature of the all pass system, clear? Right. So hope you understood that this is a very simple thing. I don't want to stress more and more here. And coming to compensators and controllers, I just want to tell you one thing, because the compensators, of course, compensators and controllers is the easy topic, right? So I will provide the note for this, because more than this, we require to discuss about the state space analysis. So everything is mentioned here. So how it is, lead compensator and lag compensator is very simple. Lead compensator means it will provide the positive phase. Look at that. What is the phase of this system now? Simple way. The phase of this system could be written as, right? So the phase of this system is equal to, so replace S is equal to j omega, then it will going to become like A plus j omega divided by B plus j omega, isn't it? So then it will going to become like tan inverse of omega by A minus tan inverse of omega by B here. Correct or not? Omega by B. Simple. So B must be greater than A. If B is greater than A, then what will going to happen? Omega by A, right? Sorry, I'm very sure if B is greater than A, then extremely happy to say that omega by B is less than omega by A. That means this value is low, this value is high. Then obviously it will become a positive phase. Correct? It will become a positive phase. If we get a positive phase, then this is called as a lead compensator, nothing else. Many of the students will think in the reverse way. They think that if it is providing the negative phase, then it is called as a lead compensator. No. Lead compensator means it should provide a positive phase. Simple. And then you all can see B should be more than A in the value wise, right? B should be more than A. Then obviously A will come here first. So this is minus A, and then here you will going to have minus B, right? So if 0 comes first and then pole, then it is going to be the pole 0 plot of the lead compensator. Clear? Then the magnitude plot like this, it will looks like starting it will not have any slope here, 0 slope, but first 0 will come, that is a corner frequency. So at A, what will going to happen? It is A with a single order, right? A with the order 1, so it will add plus 20 dB per decay. It all the way it goes like this. When the pole is encountered, then it will add the negative slope minus 20 dB per decay to the plus 20 dB per decay. Overall slope will become 0. Clear? So that means when the corner frequency 0 touches, the slope increased, and when corner frequency B touches, then the slope reduces. So increased slope with the reduction, it became a flat. Clear? So that is how exactly it is. And if you draw the plot, obviously this is the way how the phase plot looks like, right? So those who want to know how do we get the maximum phase for this? If you want to get the maximum phase value at a particular frequency omega, it's simple. Just we have seen that this is a phase function, right? So then we need to do, d phi by d omega. Simple. D phi by d omega is equal to 0. That means it is natural that if you want to get the maximum or minimum value, what we will do, we will do the differentiation and find the value of x where maximum or minimum can be attained and replace that value of x in the function. So that means similar way, if you made the differentiation d phi by d omega is equal to 0, differentiate this and equate it to 0, then you will get the value of omega where you will be getting the maximum phase. Take the value of omega and substitute in the phase function here, then you will going to get the phi max, and this is the assignment to you. Clear? This is the assignment to you. Get what is the value of omega where you will going to get the maximum phase, and also calculate that phase maximum. Anyway, if you cannot do that, no problem. It will be available after that. And everything if you reverse, then you will going to get the lag compensator. That means all the concepts are same. The only thing is here you are going to have phase, as you can see now omega by A, definitely it would be less than omega by B here, correct? because A is greater than B means omega by A should be less than by omega by B. So therefore phase of G of j omega, now if you write cleverly, what it will going to become? It will going to become like tan inverse of omega by A, of course, minus tan inverse of omega by B. Now as I was saying clearly that this value is less than this value, so naturally it will going to become negative. Clear? Rest of everything is like same like what I have told you earlier. And apart from the lead and lag compensator, we have one more, that is lag lead compensator. Clear? So lag lead means we will be seeing both lag as well as lead. Lag starts with the pole and 0 and followed by the lead which attaches the value of 0 and pole. Clear? So now what will going to be the way how the magnitude plot looks like? First we are having the pole. That's why the magnitude plot is decreasing. Correct? And then we have 0. So it is adding the slope. So therefore it is following up to here like this. And when we have one more 0, the slope is getting increased here. And then again we are getting the pole here. So again it will be flat here. Clear? But the interesting fact here is during a particular frequency, from B1 to B2, we are able to see lot of decrease in the gain. Right? So therefore it is called as band reject filter. Clear? So BRF, that means it could be called as a band reject filter. Band reject filter means some amount of the band of the frequency. From B1 to B2, we are seeing the very low gain or very low magnitude. That's why it is called as a band reject filter. What about this one here? So the lag is actually nothing but, any one of you, lag is nothing but low pass filter and lag and low. So this is the way you can actually remember lag and low pass filter. And when it comes to the lead, so lead compensator is actually high pass filter. Clear? This is considered as high pass filter. Clear? So it is increasing and at very high frequency you can see it is providing some gain, right? So that is exactly I want to say. I hope I have completed all these things, right? So there is a small concept called controllers also, right? So lag, LPF and lead high PF. Yes, lead is high PF. That means high pass filter and lag is low pass filter. And there is a concept called controllers, and this is especially important for instrumentation students, right? So what I do is only for this topic I will provide complete conclusions, right? And if anybody really want to know what is the background of this, you can even refer my lectures are available in the YouTube itself. In BYJU'S Exam Prep itself, you will be finding complete videos on proportional, integral and derivative controllers. So you can go through that. But anyway, as you guys are requesting the PDF, I will provide the PDF to you. Okay. So just as I was saying, these lectures are there in the YouTube itself. Why and how proportional controller, integral controller, everything all are available. Please go through the YouTube lectures. Then you will be getting the complete idea about this one. And you will also understand what is the importance of PI, PID, everything. And I think Pramit and Apu, those students who are really able to, who are with me from the starting, you will be seeing that. Just to go through my lectures, just randomly in the YouTube channel, you will be finding proportional controller. Or else you just type in the search tool that proportional controller by Phanindra Sir, BYJU'S Exam Prep. You will get proportional, integral, derivative, everything, complete knowledge, okay, complete package. Now coming to state space analysis, because I want to focus here more, as I know that there is obviously at least 2 marks question will come from here. Minimum 1 mark or 2 marks, clear? So now the most important thing is in state space representation, state space analysis, the first thing what is important is the state space representation. So if you take M by N system, that means M inputs are there, number of inputs are M here and number of outputs are N. Clear? So M inputs and N output systems are there, right? So then the state space representation can be written like this. Clear? Everything is in matrix form. Everything. Here A is not A. Basically A is matrix form. X of t is also matrix, B is also matrix, U is also matrix, everything is matrix. Then what is this matrix? So simple again. So in the general, we are having, if there are P states and N inputs and M outputs, fine. So I think we have reversed it, right? So N input and M output. So this is going to be, look at that, this is N here and this is M here. I am extremely sorry about this. Okay. So then the system matrix will be considered as a square matrix here, because if we have P states, order of the system is equal to number of states here. So sir, why state space analysis? Oh my god, it's a very good question, right? So see, transfer function model will tell you what is the relation between the input and output, but single input and single output. But if you want to know a system which is operated by multi-input and multi-output, how these multi-inputs are affecting the multi-outputs, then you require this mathematical tool which is called as state space. Second thing is, in transfer function model, you don't know exactly how the internal system works. Overall conclusion you will be able to know. But in state space model, you will be understanding how the internal system behaves, so that you will get a privilege and leverage to know what to do, where to do, and how to adjust the system to become stable or else to improve the performance. Basically, it is all about dealing with the multi-input and multi-output. Second thing is to do accurately such that we will get the required performance characteristics. Clear? So now system matrix and input matrix is having the size of P by N, and output matrix C is called as the output matrix, and D is considered as a direct matrix here. Clear? So those who know already state space, then you can understand the way how all these orders are coming. But my suggestion is to go one step beyond this. The very first thing is state space equation, state equation. How do we get this state equation? Any one of you, just go back once again, and here itself, if you apply Laplace transform to this one, so apply Laplace transform on both sides. Apply Laplace transform. If you apply Laplace transform, what you will going to get here? It will become S into X of S. Again, that is a matrix form only. This will become A and into X of S, right? So of course, this is, I am extremely sorry here. So look at that, X into X of S, and this will be like minus X of 0 initial condition equal to A into X of S plus B into U of S. Correct? So just I applied the Laplace transform and then I got this equation. From this equation, if you rewrite, that means take this X of S to this side and take common and do the rearrangement, then you will get the state equation in Laplace transform like this. Now my suggestion is, many students, they will be getting this, and if you want X of t, then you have to take the inverse Laplace of this. Simple, because X of t is nothing but inverse Laplace transform of this one, X of S. That's what I have written here. So the inverse Laplace of this whole function is going to be X of t. Many students, they feel that this is very difficult to remember. That's why don't remember. Okay, so don't try to remember, but know the analysis how to do that, because I told you that just take the Laplace transform of this, you get this equation, right? From this, what should I do here? Now if I continue to do, take Ax this side, X into X of S will be there, minus A into X of S will be there here. Right side you will be having like X of 0 plus B into U of S. Correct? This is easy. Now what should I say? You have to take S of S common. Right? So if you take X of S common here, so what you will be getting here? So X of S will be here, and here you will be having S is a scalar, but it is a matrix. So you should write like Si minus A, because S is a scalar, but you are taking the common as a matrix. So this should also become matrix. So therefore I should multiply with the identity matrix. So S into I minus A into X of S. Then just multiply both sides with the Si into Si minus A inverse. If you multiply Si minus A inverse, then of course this will not be there this side. Right hand side, now we will get Si minus A inverse, right? So that is what it was written like here. So X of S would be equal to, now this could be written now as, look at that. So X of 0 is there, fine. I don't agree with anything else apart from this. So you will get like Si minus A whole inverse here, and here also you will be having Si minus A whole inverse. So just let me write down Si minus A whole inverse here, Si minus A whole inverse into B into U of S here. Clear? This is what exactly you are getting here, and that's what it is called as the X of S here. Clear? So X of S came in this way, and if you take inverse Laplace, you will going to get X of t. And there is one important matrix called state transition matrix. In fact, that is nothing but L inverse of Si minus A inverse. So simple. So that is, state transition matrix, usually it is considered as phi of S, which is nothing but Si minus A whole inverse. And state transition matrix is nothing but phi of t, which is nothing but equal to e power at, or we can simply say that L inverse of Si minus A whole inverse. Clear? So have you remembered that usually whenever we have like 1 by s minus 3, what is the inverse Laplace of this? It will be written like e power 3t, correct? E power 3t. Now instead of 3, if I have a here, then what should I say? E power at. Just like that. It is 1 by s minus a is nothing but si minus a whole inverse. If you take inverse, then that is the way how you will be getting, correct? Easy way to understand and no need to complex this. And there are so many properties associated with the state transition matrix. But again, I am saying that if you start remembering the properties, in fact, even in the exam, if they give the question, if you know this basic, you can solve that question. Rather than remembering this, try to address the basics, then it is easy to solve. Clear? Now moving ahead to the transfer function. So finally, once you know the x of s value here, this is x of s, correct? So go back and substitute that x of s here. Clear? So just to take the Laplace transform for this, then you will have y of s is equal to c into x of s plus d into u of s. So once you have x of s here, take this x of s and substitute in the Laplace transform of this one. That is, after applying the Laplace transform, if you substitute, then you will get y of s straight away like this. That is considered as output equation here. Now, in this output equation, if you want the transfer function, so simple to find the transfer function here. How to find the transfer function? Initial condition must be 0. So that means this must be equal to 0. If this is equal to 0, then this entire part will become 0. Then you will be left with the c into si minus a whole inverse into b plus d into u of s. That is exactly what you have here. Correct? So if direct matrix is also 0, because most of the times in gate question this value will be 0. If it is 0, then I am very sure y of s will going to become like C matrix into Si minus A whole inverse into B matrix. Correct? B matrix. Simple. Right? So y of s is equal to this into u of s. I think u of s is not multiplied here. So it will also have u of s also. I'm extremely sorry. When we take y of s by u of s, obviously that is considered as a transfer function because this is the output by input. So this is equal to C into Si minus A whole inverse into B. This is one more important and very important result. And again I am saying it is not required to remember all this formula if you know how the state space representation can be utilized and how to take the Laplace transform and resubstitute in this thing. Because most of the times it just takes the mathematics of just maximum 20 seconds. Not even 20 seconds, 10 seconds bhi nahi chahiye. Suppose if you have great practice from this step to this step, it's just a matter of 5 seconds. Correct? And after getting that, it is very easy to get up to here and then take d is equal to 0, initial condition equal to 0, then you will get a transfer function. See, again I want to tell, there are so many students who are very mad about the formulas. You have to remember the formula only when it is really required to remember. Otherwise, it is better to believe the basics and take at least 5 to 10 questions on that formula. Automatically, you will be able to remember the formula. Clear? That's the best point. Clear? So now moving ahead, of course, controllability and observability, these are the two important topics. Suppose, anyway, I don't want to discuss what is the meaning of controllability and observability here. Right? Controllability. If you want to check whether the system is controllability or not, we will define the controllability matrix, that is phi c, which must be like b a b a square a power n into b. Of course, n is considered as a order of the system. Order of system. And if anybody really want to know and explore the physical meaning of controllability and observability, my lectures are the best lectures because I have taken mechanical system, electrical system, chemical system also as an example and proved it. Okay. So if at all the determinant of phi c is not equal to 0, then the system is controllable. Why? Because if it happens, then I can say rank of phi c matrix, it is equal to order of the system. Correct? So that means if the determinant is not equal to 0, then the rank of the matrix is equal to order of the system, then the system is controllable. And here, if at all the determinant of the phi c is equal to 0, then the system is uncontrollable. It means that the rank of phi c, that means controllability matrix, it is less than n. Clear? That's simple. So instead of looking at the rank and all these things, just calculate the determinant of phi c. If it is equal to 0, then controllable. Otherwise, it's not controllable. Clear? Yes, if it is equal to 0, it is uncontrollable. If it is not equal to 0, then it is controllable. Clear? Now moving ahead with the observability. For observability, we will take another matrix here, which is considered as like phi 0, and C is Actually the output matrix, A is the system matrix. As I said, once you form this particular vector, then our matrix, then again n is the order of the system. Once again we have to calculate the determinant of this matrix. If it is not equal to 0, then this means that the rank of this matrix, whatever the matrix we have developed here, the rank of this matrix is equal to n. Then the system is observable. In case if the determinant is equal to 0, it inherently means that the system is uncontrollable, as the rank of this matrix is going to be less than the order of the system. Clear? Order of the system. So that is all about controllability and observability. As I said, apart from these two, these are transfer function as well as state equation are the important results as well as important conclusions in the state space analysis. I hope I have done almost everything which is there in the control system. All of you please take 1 minute time for me and tell me, is this session is really useful to you or not? Okay, just a bit of statement from your side, that will really keep motivation to me, and I will come up with the lectures of Nyquist platform. Okay, so every one of you take 1 minute time and let me know, is the sessions are useful to you or not. So the first thing what you need to keep in the mind before closing this, I just want to tell you some important tips which I have observed in my entire experience and from the statements of the students, right? Okay, sir, yesterday PDF is not in our Telegram channel. Kandula, I have messaged that after today's session I will going to drop the PDF. Okay, so the first thing what you need to keep in the mind, keep the short notes as simple as possible. When you are writing the short notes, the meaning of the short notes is it is the short notes, right? Again, if you make everything in the short notes, then the short notes will become the real notes and you will really lose the intent of the short notes. So that should be one thing. Second important thing is, never try to mug up the formula. Just look at state space representation. Close your eyes. When you close your eyes, stepwise procedure should come into your mind. State space representation, A, B, C, D. What are these A, B, C, D? And then next, how we will lead to the state space analysis. All these things, you should close your eyes and then recall the things. The difference is, if you open your book and read by looking at the statements, then what does it mean? If it is there on the book, when you see that statements, then only you can remember. That is the meaning of that. If you close the eyes and if you are able to recall everything one by one, that means you are able to recall in every situation, any situation. Because once you close eyes, if you are able to recall, it means that it is there in your mind. Clear? That's the best practice. But close your mind and recall everything one by one, and that is the way how it will be stamped into your mind. Clear? And the second thing is, don't mug up the formula, rather practice and revise most of the times. Clear? So because many students, they ask the question, it is a common doubt for many students, every student. In fact, sir, I have prepared the first subject 2 months back or 3 months back. Now I am in my 4th subject. I am unable to recall the formula of the first subject. The problem is you try to mug up the things. Don't mug up. Rather, try to practice. Suppose you have some formula. Suppose let us say the transfer function of, previously we have the transfer function of this one. So this is transfer function of this. So if you can't remember this formula, solve at least 4 to 5 questions on this. Then what is the best advantage of this? Automatically you will be able to remember. Even if you are not able to remember, your memory in the hand, that will remember. Suppose let us say you have practiced so many questions on this formula, right? In the exam, okay, when you are writing in the exam, while you are doing, if you write like this, clear? By mistake, if you write like this, right? If you write like this, then immediately you will sense that something is mistake, because your hand will not allow fluently to write this one. Clear? So your hand will abstract, saying to the mind something is mistake. So that is the beauty of the practice. And you remember this point, that the memory is not only for the mind. Each and every cell in the body has a memory. Okay, that's why you should practice more. Even your hand will say to your mind that yes, you are doing something wrong. Please look at that. Then even if you are unconscious, suddenly the hand will not move fast. Then it will say, oh, stop there and look at that deeply. Then you will understand it. Clear? So this is the best way to remember and practice. And more importantly, be confident till the end and never give up anything. Clear? So most of the times I have seen this in my past experience. There are so many talented students, so many toppers. universities toppers, IIT toppers, NIT toppers, a lot many toppers, they come and prepare for the GATE examination. But in my past experience says that every time when you look at the top 100 students, you will have 60 to 70% of the students are average students. The reason is they are the students who are very consistently preparing for the examination with a lot of dedication. Clear? And GATE requires that, GATE demands that. Clear? And once again, I am providing my credentials here, and you can connect through these credentials to my Telegram channel. Whatever is required in control system, you are always ready to ask, and I am always ready to help you. And at the same time, I would like to inform you one more thing, that if you guys are interested, we will try to have some open mock test, open mega mock test, all India mock test of control system directly on YouTube, so that you will really understand what is the level of competition you can face in the final GATE examination. So those who are interested to have the open mega mock test only on control system subject, please let me know either in Telegram channel or else even in the comment section. We will definitely consider your request and come up with the best plan. Hope these lectures are very much useful. I am seeing a lot of love in the comment section, and I sincerely suggest, right? So don't give up anywhere. Move on till you win. Clear? So finally, guys, I am signing off. Hope you really enjoyed. And in the next session, you can find with one more great lecture by the experienced faculty. Till then, take care. Bye-bye. Good night. And I will share the PDF in the Telegram channel right immediately, maybe after this lecture or maybe tomorrow morning. Thank you once again.